Hello everyone, welcome to my talk. My topic today is on event streaming and processing with Apache Pulsar. And again, I'm very happy to be back at Conf42 Cloud Native 2022. This is my second year joining this conference, so thank you to all of the organizers, especially to Mark, for your help. My name is Mary Grygleski. I'm a streaming developer advocate at DataStax. And here's my Twitter handle if you'd like to get a hold of me. So who is Mary? I'm a senior developer advocate at DataStax with the streaming team. As such, DataStax is a company that specializes in data management and also in NoSQL database, as well as cloud-native database as a service managed platform. We specialize in big data. These are, we can handle data in, really huge volumes of data. And so that's about me. And before this, I was at IBM for about 3.5 years with the Java and then WebSphere team. So my specialty is in Java, cloud native, data, DevOps, and now moving into more streaming. And I also work on some reactive stuff in the past. I'm also a very active community builder. I'm the president of the Chicago Java Users Group, as well as the co-organizer for several IBM-sponsored meetups in the Chicago area. And before this too, I was a developer for over 25 years in various capacity. But primarily, I was really heads down into doing engineering work, development, and then I moved more into technical architecture. But I've involved, so to speak, in IT department, working in the trenches, doing design, integration, testing, development, deployment, and all kinds of stuff. And when it kind of, get into DevOps, I also got my hands dirty into that. So. And here are several ways of how you can stay in touch with me, my Twitter handle, my LinkedIn profile. I also have a Twitch stream as well as a Discord channel. But I will share this with you towards the end of this presentation. So here's today's agenda about event streaming and event processing using Apache Pulsar. But first, let's start out with some fundamentals, talking about what is event streaming, what is event processing? What is complex event processing? And then event-driven versus message-driven type of messaging. There are some subtle differences in there too. Very often too, we hear today, right, about events, streaming, all of these things all kind of bundle up all together. It's all about asynchronous processing, concurrency, scalability, especially in the cloud-native world too. It makes the problem even more challenging than before. Okay, so after this introduction, I'll get into a bit talking about event processing, the semantics, pubs up, queuing. These are like typical semantics. And then why event streaming, right? Why do we want to do this? And then I'll give you a bit of an intro to Apache Pulsar. And also, Apache Pulsar depends very heavily on Apache Bookkeeper as well as Apache Zookeeper. So I'll give you some kind of background information to that. And then essentially too, Apache Pulsar is meant, in my opinion, is really like meant to extend what we have today. For example, like Kafka. Kafka does its job perfectly well, but there are certain limitations. So this is where Pulsar can come in and augment, the situation, make it even better. So with this, let me start this talk. Okay, the many facets of computing events. So first of all, right, what is an event? And also bear with me too if you are, coming in here already knowing some of these, but I have to assume that not everybody has this background. So I want to go over some basics. So what is an event? Like generically speaking. So for me, I looked up the dictionary, Merriam-Webster.com right away. First of all, something like really common to any kind of scenarios for events, they are really about something just happens, an occurrence. Now, as I kind of page through that list of interpretation, number 4 really caught my attention. It's essentially talking about events being the fundamental entity of observed physical reality represented by a point designated. So what is this point? This point is designated by 3 coordinates of place. So the x, y, z coordinates, and then also one of time, so in the space-time continuum, and postulated by the theory of relativity. So it essentially do in computing, and that's how we look at events. Events is essentially an occurrence that happens in time and is represented by the point that's actually then by the 3 places, right? The 3 coordinates of place. So X, Y, Z, and then in time too. So I feel that is really an exciting topic. It gets more into the abstract, but also too, if you think about it, events actually are more attuned to what human beings are. In computing, I think when we're all first learning about computers, we're kind of, looking at things very mechanical, so to speak, right? We define data, we flatten out whatever it is and define, or maybe like flatten out some structure, right? We kind of like assign that kind of like properties to your objects, and then trying to make sense out of it and then do the computing. It's actually a bit kind of awkward if you think about it, right? All of these processing we used to do would be synchronous, right? It's blocking. If you issue a request, for example, like in HTTP, even in web interaction, HTTP protocol is a stateless protocol. So you issue a request, and the request essentially has to wait. You send the request over, you have to wait for the response to come back before you can proceed. So it's a very blocking, very time-consuming type of protocol. And it doesn't really mimic what human beings do, we do. Well, do we actually wait? If we, even like talking on the phone, and as you can see, talking on the phone, real-time communication actually isn't all new. If you think about it, our telephone systems is essentially real-time communication. But think of the fact that if we do it synchronously, wouldn't it seem kind of awkward? Like if we call someone, I guess it's probably like the old walkie-talkie, right? When you talk about something, only one person can talk, and when you said, when you're done, you say over, and then the other, your sender, receiver, or the both persons in the conversation will have to kind of take turns to speak. So it's a bit kind of like less kind of natural. But again, this is events. We want events to essentially help with human conditions and make things happen a lot faster. So first of all, what is event streaming processing? It is really the practice, right, of taking action on a series of data points, that originate from a system that continuously creates data. So I know it's like a mouthful. But event essentially refers to each data point in the system. If we represent the stream, right? The stream then basically refers to an ongoing delivery of those events. So stream can be, if you represent in a straight line, it can be many events that are represented by dots that happen, in time. So this is essentially how you can represent events. And a series of events can also be referred to as a streaming data or data streams. How about complex event processing? So complex event processing, CEP, is a set of techniques for capturing and analyzing the streams of data as they arrive to identify opportunities or, threats in real time. So we find that, for example, some kind of security scanning, monitoring, they are really kind of involves complex event processing. If something happens, it triggers some alarm, that type of scenario. So CEP enables systems and applications to respond to events, to trends, and then patterns in the data as they happen. So that's complex event processing. Essentially, I think we deal with this every single day in our lives. So we want to do that in computer. Okay, and now, event-driven versus message-driven messaging. Event-driven, right? This interpretation I take is actually from Lightbend, the company that makes Akka, the reactive framework, right? Akka reactive systems that abide by the reactive manifesto. So that's event-driven. What it says is sender emits messages and interested subscribers can subscribe to the messages. So that's event-driven. Now there's also message-driven, but as such too, let's go back. Event-driven, think of it more like what we call publish, subscribe, or producer-consumer type of systems. So the sender basically sends the messages without having to worry about who's gonna receive it. It's up to the subscribers who are interested in it will need to subscribe to the messages. And that's how it works. Now for message-driven, it's not the same. It's basically sender and receiver, they already have to know, they are known to each other beforehand. So the address needs to be known. So that's message-driven messaging. And usually message-driven is really about like two parties that are communicating with each other. So they know each other, who they are. So as you can see, these are differences between the two event-driven and message-driven messaging. And now, if we look into it, right, what happens then before taking an event approach? I mean, think of it in today's IT system, in the IT department, right? There's still a lot of batch processing happening. And essentially, this is just what's happening, right? We collect all of the data and then, kind of group them all together and then batch them up essentially, and then have the processing going on perhaps in the middle of the night when nothing else is happening. So then you don't, take away processing capability in your system to kind of crunch through all of these heavy data set. So that's what happened, right? Especially in the 90s, in the early 2000s, a lot more batch processing. But as systems becoming more sophisticated, then we're seeing more and more event-driven type of systems that comes into play. Now, don't get me wrong, batch processing still has its place and it's still very relevant, especially if you are in IT department that are dealing with kind of like a system of records, like you processing something that can be done in batch. I believe too, even a lot of machine learning processing also being done in batch. The reason is that the data set is just too big, it's hard to like all processing them all in real time. But then this is the reason why we want to develop, systems and capabilities such as Apache Pulsar is targeting for really the big data set. And that's what it is. So now let's take a look then into event messaging, some semantics and patterns. So streaming, right? So streaming, this is what we are kind of all about, and my job is essentially about advocating for streaming. So streaming, when we talk about streaming, is really referring to the the publish subscribe type of a paradigm, right? So publishing client will sends the data, and then in a PubSub system, there's also always like a middle person, the agent in the middle, called a broker. The broker is the one that's kind of like mediate and everything. So it receives the messages from the publisher. Publisher sends the data and broker gets it. And then based on a lot of different types of configuration parameters, the broker will deliver the messages to those who are interested in the messages. So it requires subscriber to subscribe to it. So the subscribing client will receive the data, but the subscribing client will have to initiate and subscribe to the topics, right? So very often in a PubSub system, we're talking about using topics, like Kafka is using topics, Pulsar has it, and even IoT messaging such as MQTT also is a PubSub system that has topics. Topics essentially just label so that you group all of these messages together, and then essentially those who are interested will have to subscribe to that topic to receive it. Message queuing. So what is message queuing? So message queue is a form of asynchronous service-to-service communication used in serverless and microservices architectures. Messages are stored in the queue until they are processed and deleted. So essentially, first in, first out type of principle applies. And the messages are only intended for one single customer, consumer. So only process only once. And message queues can be used to decouple the heavyweight processing to buffer or batch work and to smooth out any kind of spiky workload. So as you can see, the queuing helps to in kind of offloading some of these heavier processing. So that's what message queuing is. So about event streaming. So why event streaming, right, at this point in time, right? So earlier I talked about event streaming is because it really mimics the more of the human behaviors, a lot more natural to us, but it's also at the same time much harder to do because now we're bringing into concurrency, bringing into events that are happening at different times. It doesn't happen yet, and you have subscriber waiting for it. So it kind of involves a lot more computing. Well, kind of managing the computing at the back end too. So it's more complicated, but you reap the rewards, the benefits of it being real time. So that's what it is. So what's driving this change, right? So if you look into it, we use real-time data to enhance customer experience, right? And create a competitive advantage for your business. So on a high level, that's what it is, right? Marketing people, we like to talk about, advocating for real time. Essentially, two things happen right away. If you are at a football game, you want to know the statistics of a player right away. It can be streamed, that data can be streamed, immediately analyzed and output for you within like seconds. You can get that kind of a data. So that's kind of like some advantage of that. And then there's also data pipelines too, right? That's actually very useful to build AI and ML, machine learning, smart models from time series event streams, for example. So that's kind of data pipeline is another like good usages of event streaming, or kind of like how event streaming can help with building data pipelines. And then also, one important aspect of event streaming is it allows for scalability, elasticity, is to happen a lot more, in a more flexible way. It helps to meet the demands of large volumes of data generated by application operating at the edge, IoT systems, for example. If you use like a PubSub kind of broker, you can actually have like a billion, or not even billion, maybe like a petabytes of data within, well, I guess maybe I'm exaggerating, but there's been actually a benchmark being done to like 100 billion messages being published with the topics too, like that. So things like that, right, is really the scalability aspect that it helps, especially in today's cloud native world. Now, then why event streaming? So let's talk a bit about it. We want to watch for events with the system or application. And you want to also like subscribe to topics to see certain event types, right? And then you want to make decisions on data in real time, not after the event. You want things to happen. You want to see the data. You want to see it being transformed and churn out some useful data for you. The real time aspect is what is kind of, the core of why we want to do event streaming. We wanted to be able to ingest high frequency of messages, but with very low latency, right? There's not much of a gap in between when you receive your messages and then being able to process and output it to, some format, for example. So essentially, it's the real-time aspect. And now comes Apache Pulsar. So what is Apache Pulsar, right? So as such, Apache is Apache Software Foundation. It is open source, governed by the Apache Software Foundation. There's like proper top-level project. It was actually open source by Yahoo. It was first developed by Yahoo back in 2015 or 14, that time frame. Then Yahoo contributed it to Apache Software Foundation in 2016. And then in 2018, within like less than 2 years, in fact, it already became a top-level project. The reason is that it's really built in a lot of the capability of doing cloud native that is really more lacking in most of the other systems, in fact, all of the other systems. So that's where it kind of comes out kind of outstanding in that regard. It is, again, cloud native design is cluster-based, multi-tenancy, and the client API, surprisingly, isn't like way too complicated or anything. It supports Java, C#, Python, Go, JavaScript, among others. Scala too, for example, if you want JVM languages, it's also supported. There are others ones too, so you can check the website. And basically, the key of it is that Pulsar separates out the compute and the storage, and that's what makes it a lot more easier from the scalability kind of perspective. And another thing to Pulsar, being a PubSub broker, it has built-in already like guarantee message delivery mechanism in there too. So if a message successfully reaches a Pulsar broker, it will be delivered to its intended target, right? So depending on the message level, for example, quality of service, right? It can be quality of service level 0, it's fire and forget. Then in that case, the broker isn't held accountable for kind of guaranteeing messages delivery. And then you can have QoS 1, which is like 1 or more delivery, or QoS 2, which is exactly 1. So that's a lot more precise with QoS 2. So all of these are being supported by Pulsar too. And then it's such to Pulsar is very lightweight, serverless, has a very lightweight serverless functions framework too. It's called Pulsar functions. And it creates complex processing logic, right, within a Pulsar cluster, right? For example, if you're building data pipeline, you want to kind of fetch the data and you want to do some work of transforming your data or mediating it or whatever you need to be doing. So you can leverage on Pulsar functions to help you to transform and mediate all of these messages too. So it kind of makes it it comes in very handy. It has already command line that helps you to deploy, build your function and then deploy, eventually kind of get it running, right? Or you can kind of do it using the console. For example, I work for DataStax now, so we also have Astra Streaming, which is the commercial version. AstraDB is the commercial managed database, Cassandra database. And Astra Streaming is attributed to the streaming that Apache Pulsar enables Cassandra to have. So then you really enable more of the real-time processing aspect, right? So you can actually use Pulsar functions to do data transformation as well. Okay, that's just an example. And then there are also like the storage offloads too are also like tiered storage offloads. So it offloads, so what it means is that it offloads data from hot and warm storage to cold and long-term storage when the data is aging out. So when it's kind of fresh, maybe you still keep it, right, in hot or warm storage, right, or in memory as well. Or essentially too, I wanted to bring out is the Bookkeeper. And so basically it knows, right, it has built-in capability to recognize that if some data is kind of aging out, not being used as much, then we may as well write it, store it into persistent long-term storage and cold storage, kind of like that. So essentially Pulsar has this built in to handle the tier storage offloads. So again, what is Pulsar, right? Let's give a bit of some detail about it. So it's a unified distributed messaging and streaming platform. So what does it mean, right? So basically too, it supports messaging. It supports messaging, not only pops up, but also the queuing too. Not only the messaging itself, but it does transformation and mediation through, Pulsar function and things of that nature, right? So it's really a truly distributed messaging platform that's suited for today's cloud-native world. It's open source, right? Again, it came out from Yahoo, now part of, Apache Software Foundation, and in fact, one of the fastest growing projects with a lot more committers, as you can see over on these graphs, right? So GitHub stars has increased, since is becoming like 2018, right, when it kind of became top level. Is you can see too is like a kind of a big kind of jump to June 2021. And so are the number of contributors and monthly active contributors. Actually, we kind of overcome that in June of 2021, overcome that of Kafka too. So as you can see, it's gaining popularity. And again, cloud native ready, Kubernetes ready. There's also a Cassandra, or actually I should say Cassandra is more like that's Kubernetes for Cassandra. But the thing is too is that Pulsar is almost like it's basically all ready to work with Kubernetes and with Cassandra too. And it supports multi-cloud and hybrid cloud. And in fact, I will share with you a link to how you can actually quickly test out Pulsar through the Astra streaming too shortly. So 4 reasons why Pulsar is essential to the modern data stacks, right? Okay, so we'll look at that after we kind of show you a bit of information too. Who else is using Pulsar? Look at these companies, right? Comcast, Yahoo, Overstock, Splunk, General Motors, Iterable, Cargill, Verizon, Tencent, Sharpin, Nutanix, all of these. So these are like major players too, like pretty major players, right? And then also, sorry for this kind of more marketing, slides too. I know I'm talking to developers, but I hope you appreciate that too. The fact is that there's been some, comparison too. It really lowers the 3-year cost compared to Kafka too because of its capability. So it's higher performing, savings for high complexity scenarios, and savings for higher data volume scenarios too. So. And again, some brief history of Apache Pulsar, but it's actually, I already talked about it, so I won't kind of go through all of it again. It's cloud-native, distributed, unified messaging and streaming platform, has been open source as Apache top-level project since October of 2018, and we just seeing the trends, it keeps growing too. So, and as you can see, it also has the Log4j2 fix back in December too. As soon as that came up, the community already delivered a patch for that quickly. So now let's kind of go a little into more of the Pulsar. It is different, right? So why is it different, right? So here it is. I just want to point out to you, there's a producer. So client application sending messages to topic, right? Managed by the broker. It's up to the consumer, the ones that are interested in consuming the messages. I'm interested in that. I need to subscribe to the topic, right? Of where I know the producer is gonna essentially send the messages to. So consumers subscribe to the topics, and basically, then there's the broker. The broker essentially is a stateless process that handles incoming messages and message dispatching, communicates with the Pulsar configuration store, and store messages in the Bookkeeper instances. So this is the broker itself actually interacts with the Bookkeeper as well. So what is Bookkeeper, right? So again, right, Pulsar is unique in the sense that it doesn't want its compute side to kind of be worried about doing bookkeeping. As we all know, right, as human beings do, if we doing accounting, do we like accounting? Most of us don't, because it's crunching through a lot of numbers and all of these things. So it's kind of like, tedious, right? A lot of these tedious work, but yet they are utter importance too. So Apache has a project called Bookkeeper. Essentially, it does electronic ledger and journals and all of these things. Kind of, if you are accounting kind of an enthusiast or you're familiar with it, then you're familiar with those terms. Essentially, it's just bookkeeping being electronic, going digital. And that's what Pulsar leverages on for is logging, storing all of these things, right? And so as you can see, Bookie itself, has different segments in the storage, kind of for better organization and managing and faster retrieval and all of these things too. So Broker is the one that's serving, but it also interacts with the Bookie. Now, there's also Zookeeper. I bet some of you, or most of you probably already know of Zookeeper. That's actually, it's more like it manages the cluster, right? The metadata, the coordinating tasks between different Pulsar clusters. So as such, right, the name Zookeeper is basically to keep order in the zoo. So as you can imagine, right, this whole how cloud native thing can becomes very, very confusing. So Zookeeper comes in, manages all of these metadata, handle all the coordination, making sure nobody steps on each other's toes, essentially. So that's essentially a Pulsar component. Just wanted to highlight too, the design principle of Pulsar, it has adopted a tiered architecture design kind of approach, right? And it's a traditional multi-node architecture. So as you can see, right, we already looked at producer, consumer, they interact with the broker. Producer sends message to the broker. Consumer is interested in it, will subscribe to the topic, right? It's actually, I should say, producer sends messages to the topic, and basically it's the broker that's kind of manages, right? But essentially, too, broker also will have to acknowledge back, on the network kind of layer, too. So, okay, so as you can see, too, topics, too, can be partitioned off, too, as you can see. So broker has different topics being partitioned off. And essentially, too, this distributed architecture supports, like, horizontal scaling really well. And partition topics to abstraction, mask complexity for consumers, right? So consumer don't have to worry about it. It's the broker that manages all of these topics partitioned too. So common challenges, right? What are some of those? So essentially, if you look into it, why, right? Why using Apache Pulsar? If you look at it, traditional scaling will require partitioning, rebalancing, all of these things. And having Pulsar actually separate up the compute and the storage, it helps with the scalability and rebalancing much more like cleaner than it would be if you have, a component that kind of combines both compute and logging, right? So if you need to rebalance, how do you do it? It's quite a messy situation. But if you separate out the concern, they each takes care of things kind of independently, but yet they are all tied together too through the broker. So tightly coupled persistence and message service capabilities impose high costs on historical data. The trade-offs to support partition topics came at the expense of messaging semantics needed for use cases, such as queuing. So as you can see too, it's basically, if you don't kind of have, separate out this concern, then basically, too, the messaging semantics will have to kind of take care of use cases such as like queuing. Essentially, that's what it is. So, okay, let's take a bit another look too into this tiered architecture design of Pulsar, multi-node architecture. And so, what's the big deal, right? So essentially, it's fast, it's low impact. It's horizontal, it supports horizontal scaling, and reduce the CapEx and OpEx too, which is like capital expenditure and operation expenditure at your company. So Broker is stateless, and it has built-in load balancing, and the scaling is pretty instantaneous. And essentially, disaster recovery is zero impact, so any time, right, you need to have recovery of these things, it pretty much can kind of like scale up and down and takes care of thing itself. If it is disaster recovery, you need to like duplicate certain like setups and stuff. So that one too, because of the nature of the design of the multi-tiered architecture and separation of compute and storage, is actually make it a lot more flexible, more dynamic in that sense. Now let's get into Bookie a little bit. So Bookie again, is the bookkeeper. Very scalable and is wall-based. So this is the write archive, base, but this is a protocol that helps with the writing, right, of all of these log records too. And it kind of helps with the ordering as well. So fault-tolerant and low-latency storage services. Tunable consistency for message replication, the ensemble size, write quorum, act quorum, all of these things, right? So you can tune that too in Bookkeeper. So as you can see, right, if you kind of lump all of these, right, into Pulsar to do it, it will be overburdening Pulsar. So that's why Pulsar doesn't concern itself with things like that with bookkeeping, because Pulsar is a lot larger. Well, I shouldn't say larger, but it has its own fish to fry, right? That's important to handle all of the brokers, all of the messaging guarantee, all of them. So I don't want to like overburn myself and having to worry about bookkeeping. I let Bookkeeper do it. So the Bookie. So as you can see, right, they're also journaling in Bookkeeper. And it's essentially too, it enables like fast write is guaranteed. It's through the journals. And then ledgers too, electronic ledgers are basically segment-centric data persistence via ledgers too. So as you can see, it goes very deep into Bookkeeper. It is a library, a project of its own under Apache. So you can always look that up for more details as well if you like. But for this particular presentation, I won't go into all the deep details, not just yet. So. Okay, so essentially, then we look into the capability of Apache Pulsar. So what problems is it kind of trying to solve? So essentially, too, it solves also the problem of bolt-on, because it represents the next generation of enterprise messaging. So think of it more like, not coming in as a disruptor. Disruptor in a sense, but it doesn't really disrupt you, meaning that if I'm on-prem, just keep going on-prem. I don't worry about it. Just essentially plop in Pulsar, right? It's like a big giant like bolt-on, just kind of like, nail it in and it can work too. You can configure, obviously, and then you can get your whole thing running, as is, right? For example, this picture in here, you got Kafka, JMS, Java Messaging Service, RabbitMQ. All of these are a bit of an older messaging now, but you have it in your company. You don't want to like quickly, change it again. It costs a lot of time and money too. So you want to keep using, because it contains very important business knowledge that will be hard if you try to migrate. So you can keep those, and in the meantime, kind of drop in Pulsar, and Pulsar is non-disruptive like this. You just plug it in, and then it will get to work. Why? Because it is actually a unified solution. It comes in as like an ambassador, like a unifying everything. A unified solution for PubSub, for streaming, for messaging, right? For queuing, and also for, the messaging, mediation, and enrichment, the transformation, all of these, if you think of, this kind of capability, I don't think there will be another project out there, a library out there that can support all of these, right? All capabilities of PubSub, queuing, streaming, message mediation, and enrichment. And then out-of-the-box capabilities include, right? So think of the fact that you can run on-prem or hybrid. Geo-replication, that's a big kind of thing of Pulsar as well, meaning that you want to do replication across geographical area. It already has a lot of the very useful kind of even like user-level capability built into, and we'll take a look at the next couple slides. So geo-replication, multi-region support, right? So you can have multiple regions too, maybe even within a geo area. It has kind of fine-grained support too for each area. You can have different countries, right? Let's say a huge enterprise corporation, you have different kind of rules and everything. So you go to different regions, they have different rules, and basically it's a matter of configuration within Pulsar. And there's also, like, if you get into data lake, right, data mining, all of these too is also supported, and much, much more. And it's only we're the tip of the iceberg, right? The project is still quite, not that old yet. There's still a lot of things being planned for it. So, okay, so basically it unifies for all events, right? It's a unifying platform for all events in the enterprise. So essentially it's like the same kind of picture, but in this particular case, you can have this already on-prem too. And Pulsar will help you do your job with very minimal disruption. Okay, here's another picture too. So unified infrastructure with built-in geo-replication. So as you can see, multi-cloud, hybrid cloud, multi-region in here. And if you look into right-hand side too, if, you have a company, right, a lot of large corporation too, can have systems that are, very complicated. It's got like really like a zoo, right? You look at this example, you get almost all data, all software that you can think of, right? Oracle for database, right? Traditional RDBMS, Postgres, MySQL. Then you have cloud messaging, Amazon, SMS, and Confluent. And then there's also programs, right? Different types of programs, Python, Golang, Java, JavaScript, all of these things, NoSQL database, right? Cassandra, for example, MongoDB, and Redis, and whatever you want, right? So all of these can coexist. Don't kind of get rid of things, just keep running. Pulsar will come in and enable and augment everything. That's what the goal, the benefits of Pulsar is. So if you take a look into it too, it gives this universal upstream connectivity and also universal downstream connectivity as well. So if you look below in here too, you can also connect to streams, analytics, and processing like Flink, Spark, Databricks, all of these other things too. So as such, and there's data lakes and warehouses like Amazon S3, Snowflake, and Hadoop, for example. And then if you're traditional messaging, Java, JMS, Kafka, and MQ, it also has the compatibility layer that's kind of built to talk with them too. So it is really like positioned itself very well. So how is it Pulsar is different, right? So it's the next generation architecture, provides a distributed tiered architecture. It separates compute from storage, and Zookeeper holds metadata for the cluster. Stateless broker basically handles producers and consumers, and storage is handled by Apache Bookkeeper. So that's something we already talked about in a couple slides back. So now this is like a rich ecosystem of connectors and clients. There are plenty of connectors too, and a really common one. For example, you can build data pipelines and send data into a sink, right? It can be an Elasticsearch. It can be MongoDB, right? Hadoop, Haskell, Cassandra, ClickHouse, all of these, Flume, all of these. So the possibilities are limitless, I should say, no limits. So, okay, so Pulsar features rapid patching, zero downtime, multi-tenant, right? So essentially, too, you can have soft isolation via read-write, I/O separation, independent storage quotas, and message flow control and throttling mechanisms, too. Hard isolation, too, you can do via physically separate brokers and bookies for tenants too. So very flexible in terms of the multi-tenancy type of capability. There's also IAM, the identity and access management, that are pluggable authentication supporting TLS, right? SSL's next generation of version of SSH, that's TLS, JOT, JWT, OAuth, Authents, and or Athens, and then the Kerberos. And role-based authorization provide control at the cluster, tenant, message producer, and consumer level too. There's also provides you end-to-end encryption. In transit, kind of TLS encryption and application managed content encryption too. So you can kind of be, rest assured your data will be safe. So key differentiator, number one, separation between compute and storage. Like I kind of talked about it already. So that's why your scaling can be independent. You don't interfere with each other. Storage is handled by Apache Bookkeeper, segment-centric message storage management, fast and low impact horizontal scaling capability. The next thing is about native geo-replication, right? You can have hands-off real-time message replication across data centers too, so which is real nice, right? So meaning that you can have, data center in Europe, in North America, all of these places, it handles all of the geo-replication for you. And it helps you to meet your data compliance requirements across geo regions as well. So that's kind of a really big plus in there. Now, there's also multi-tenancy too, as I kind of talk about. It's like an apartment building, right? You have independent unit, they are isolated from one another, but they all kind of being handled by Pulsar too. So likewise, it's in a company, you can have a Pulsar cluster. Then in it too, you can separate out according to function. You can have a tenant for finance, and then another tenant for marketing, another one for product, for engineering. Within each, they have different namespace that handles different functionality. As you can see in here, you can have a namespace that's kind of a microservice that actually handles, message topics and everything. Then there's also marketing, right? You can have different kind of a namespace for handling like, campaign manager, lead generation, all of these good stuff. And then there's also then finance, right? Fraud detection, for example. So all of these things too, as you can see, right? It is already kind of built in, and it's not too complicated. Some things are just by configuration. Then your system is up and then can handle all of these kind of like capabilities that otherwise you have to write yourself, right? Number 4, so flexible message processing model. So as you can see, right, pops up kind of a model, or you can do queuing too. But the thing is interesting too, as you can see, right, in the topic pops up, you can have exclusive in terms of subscription, exclusive subscription in which a consumer can, and the topic are kind of tied very tightly together, is exclusively for that consumer. And then another one would be a failover type of scenario. You can have two, more than one consumer. So, but only one is the primary. So if something fails, then the other consumer will kind of step in to take charge, essentially to receive the messages. And then there's also like shared subscription. So shared is kind of a very important concept, especially in a cloud native environment. You can share the subscription, and basically too, it's part of it also for cost computing, right? If you kind of use any resources, you'll be count by, how much cycles, CPU cycle you're using. But if you use a share subscription, you actually are saving costs in terms of the cloud native costs too. And then there's also special kind of key, it's called key shared. So everything is then kind of essentially represented by the key too. That's key shared. Okay. And basically, it's good fit for queuing use cases as well. And Kafka has challenges in that. So why Pulsar, right? So a bit kind of wanting to like to talk a bit too about why, is it better than Kafka? I wouldn't say it's like all better. Sometimes it depends on what your scenario is, right? If you are in a situation you don't need all of these, fancier geo-replication and giant kind of like setup, then maybe it may not apply to you. But if you are interested to read about it, there's this link in here. And under Confluent, there's a topic written about Kafka versus Pulsar. And then another one is Kafka versus Apache Pulsar, event streaming comparison, and then the features myths explored too. So when you should consider Pulsar, if you need both queues like RabbitMQ and stream processing like Kafka, or you need easy geo-replication, multi-tenancy is a must and you want to secure the access for each of your teams. And then you also want to persist all of your messages for a long time, and you don't want to offload them to another storage. And essentially, too, performance is critical for you, and your benchmarks have shown that Pulsar provides lower latency and higher throughput. So essentially, too, yeah, you can guarantee the performance to be quite well. And if you run on-prem and you don't have experience setting up Kafka, but you have Hadoop experience, these might be reasons why you want to use Kafka. So DataStax flavors of Kafka, I will go, of Pulsar. So I'll go real quickly. So DataStax is essentially taking Pulsar 10 times further. We have added our special sauce, right, so to speak, right? So all of these things are already there, and it's binary compatibility with JMS, MQ, and Apache Kafka. We have like libraries that helps you to, for legacy kind of systems like transformation, we have that migration for you too. So think of us more like, we enable you to be even more productive. So Pulsar meets you where you are. So again, I mentioned already Astra Streaming that has managed Pulsar. There's Luna Streaming. It's basically the open source, but we also provide or give you the options of purchasing enterprise support Pulsar. And enterprise support that will support Pulsar. And then there's also the pure, if you want to go all open source, you can kind of use the open source version. It's all community driven. Comparing against Kafka. So some of these pain points, I just want to highlight a few, right? So basically, Kafka doesn't have the separation of the compute and the storage. So it is, when you start off, is maybe more straightforward. You know how many topics, how many partitions, number of brokers you plan out ahead of time is there, and it's fine. However, if there's a need for you to keep growing your system, then it may become a little bit more difficult, because what do you do now? You already have defined the number of topics and partitions, right? If you want to do that, it's a bit harder to do. You can do it, but it just requires a lot more work, right? And essentially, too, if you look into it, right, cluster rebalancing can impact the performance of connected producers and consumers, too. And over here, too, it talks about, there's geo-replication mechanism, too, by, for example, this library called Mirror Maker. But it's not very ideal at this point. And companies like Uber have also created their own solution to overcome this kind of issues, too. So overall, you can look at Pulsar as an extension, right, of augmenting what Kafka, not augmenting it essentially, right? So partition-centric versus segment-centric, I think I already showed this to you. As you can see, it compares Kafka, which over here, right, the partition, everything Kafka manages is storage too. So all log segments are replicated in order across brokers too. So, and then otherwise too, if you look into Pulsar, right, Bookkeeper, as you can see, Bookkeeper handles all of these magic essentially for you, for the ledgers, for the journaling, bookkeeping. So so it becomes easier if you try to replicate, do any kind of like multiplying and things like that too. And it essentially is built more for kind of like the scalability, and it needs to rebalance, right? That's another thing. You need to rebalance if you need to grow your system, have more cluster, more nodes, and it actually grows nicely because Pulsar already has built in that it knows to kind of rebalance all of these topics, how it is being partitioned, for example, and things like that. So. All right, architecture advantage, right? So compute and storage separation, we already talked about it, and segment-oriented log messaging too over here. So where to go from here? And let's keep in touch. Okay, so here I think I'm running out of time now to kind of do some demo, but otherwise too, I wanted to bring to your attention, right, these are the resources: pulsar.apache.org, bookkeeper.apache.org, zookeeper.apache.org. You can read up on all of the details. And then at DataStax, we offer Astra streaming over here, or Luna streaming, right? Luna streaming essentially is all free unless you want to purchase the enterprise support too. So again, DataStax is very much about open source too. We are strong supporter. We have folks working on Cassandra and Pulsar, committers and PMCs. So, and please follow my Twitch stream every Wednesday at 2 p.m. US Central Time. I have my Twitch stream that these days I'm going into talking more about event streaming and Pulsar. I've been with DataStax for a little over a month, so I haven't got as deep yet, but I will. So. And then I also have other topics too, like developers chat, for example, last week at DevNexus and things like that. So, and please join us at the hood. You know, this is all new. We're efforts of starting off a website called Apache Pulsar Neighborhood is over here. Or like, you know, there are meetups too on meetup.com, meetup group. So please follow us too over there, Apache Pulsar Neighborhood. And with that, I want to thank you all. Thank you for listening to my talk. And please, I welcome you. Please stay connected with me. Join my Discord server. I'll be happy to talk about anything, right? And also follow me on Twitter. And also my LinkedIn handle is right here. With that, thank you very much.